This example is slightly different. We have y equals n minus x. Now, the first thing you might notice about this is that this is not in y equals mx plus b form. In fact, usually, if we're given something like this, they want us to jumble it up. The thing about jumbling up equations is that any signs that are in front of numbers have to stay with those numbers. So if I wanted to rewrite 10 minus x in mx plus b form, the negative sign would have to stay with the x. And I could rewrite it as negative x plus 10. Since 10 does not have a symbol in front of it, it's assumed to be positive. Using that, I can get m and b. M is the number in front of x. All I have in front of x here is a negative sign. If there's no number, then we assume that it is 1. Since this is negative, we assume it's negative 1. The number for b is added to the end is plus 10. So b equals 10. Now this is going to be kind of tricky because b is way off of our graph. So my scale isn't going to work here. You see here I have 1 and 1. That means this is 1, 2, 3, 4, 5. It's not tall enough. What I'm going to do is I'm going to scratch this out, and I'm going to change my scale. I'm allowed to do that. I can change my scale to whatever I want. And in fact, I'm going to change it so that this is 2, 4, 6, and 8. So that means this would be 10. And I'm going to do the same thing on this side, which is going to be 2, 4, 6, 8, 10. We want to pay very close attention to what the scale is, because that determines exactly how it's going to look when I plot my point. Now, using this new scale, counting by 2s instead of 1s, I can plot b at 10. So that's what I'm going to do. b is 10, so I'm going to plot it up here. M moves down 1 and over 1. So we can move down 1 and over 1. Since I'm scaled to 2s, counting by 2s instead of 1s, I would actually have a point right in the center. However, I'm lucky in that the slope is adjustable depending on what the scale is. So since my slope tells me to move down 1 and over 1, I can move down 1 and over 1, and it will be just fine. So that's what I'm going to do. I'm just going to plot a whole bunch of points. Notice that even though my scale is in 2s, my slope looks the same. Now, I have points. I can draw my line. And it looks like this. Now, the next thing we're going to need to do is graph something that is in standard form. Standard form is different from slope-intercept form, and it looks like this. Ax plus by equals c. A, b, and c are all numbers, and a and b are not both 0. One could be 0, the other one could be 0, but they both cannot be 0. It doesn't matter what numbers a, b, and c are, and what's going to happen is we're going to switch them out. Sometimes these will be a, b, and c, sometimes something else will be a, b, and c. The quickest and easiest way to graph a line in standard form is to find the x and y intercepts. And we're going to do an example where we see that. I'm given this equation, 2x plus 3y equals 12. 2 is a, 3 is b, and 12 is c. So this is in standard form. Now what I want to do is find the x and y intercepts. Let's start with finding the x-intercept. To find the x-intercept, I can simply assume that y is 0. If I assume that y is 0, then 3 times 0 goes away. So if I'm finding the x-intercept, I will simply cancel out the y. It will go away. That will leave me with 2x equals 12. I've completely ignored 3y. I can divide both sides by 2, and I get x equals 6. So my x-intercept is where x equals 6, and I'll go ahead and plot that. Since this is the x-intercept, that's where it crosses the x-axis. And it's at 1, 2, 3, 4, 5, 6. Here's my x-intercept that I just found. Finding the y-intercept is very similar. If I want to find the y-intercept, I can simply ignore the x factor. So that means that 2x I will ignore. When I do, I've got 3y equals 12. 3y equals 12, divide by 3. And I get y equals 4. So my y-intercept is where y equals 4. The y-intercept crosses the y-axis. So I go up 1, 2, 3, 4, and there's my y-intercept. I have an x-intercept, I have a y-intercept. As I said before, anytime I have 2 points, I can graph the line. So I'm going to graph this line. And there it is. This is the line for 2x plus 3y equals 12. We have a couple of other situations that might show up. One is if we're given an equation that's represented by the form x equals c. If that happens, then we have the graph of a vertical line. We should remember from our notes on slope that a vertical line is where the slope is undefined. There is no m at all. And in those cases, the equation that we would write would be x equals c, where c is the x value of the line. Now, just knowing that, I should know immediately that my line is going to be a vertical line at whatever the x value is. In this case, x equals 3 means that I'm going to have a vertical line at the point where x equals 3. So we go on our graph, we look at 1, 2, 3. I'm going to have a vertical line that crosses through this point. And I can just quickly sketch out a vertical line crossing x equals 3. The same sort of thing happens with an equation where y equals c. You'll notice that in this case we don't have an x term. If we don't have an x term, that means that the slope is 0. And we know from our notes on slope that if the slope is 0, we have a horizontal line. Very similar to the x equals c graph, the y equals c graph will be a horizontal line at whatever the y value is. So, in my example, I have y equals -2. That means I'm going to have a horizontal line at y equals -2. And that's right here. So I can quickly sketch out a horizontal line where y equals -2.